Let's work through 3 examples to determine if the following functions are inverses. And we're going to check if they're inverses by using function composition, both ways. I need to find f composed with g of x and g composed with f of x. If, and this might be a good thing to put on this slide in the future, if f composed with g of x equals x, and, so both must be true, g composed with f of x equals x, then they are inverses. So using the power of function composition, let's test this out. So first I'm going to take f composed with g of x. By now we're really good at function composition. We aren't really focusing on the domain and ranges. We just want to see if these functions are inverses. So I'm going to take f of g of x. That is, I'm going to substitute in g of x for x. So I've got the cube root of x plus 1 cubed minus 1. Cubes undo cube roots, so I've got x plus 1 minus 1 and x. These two functions are inverses. Woohoo! Next, let's take g composed with f of x. So I'm going to take g of f of x. So I'm substituting f of x into g. So I have, this is equal to the cube root of x cubed minus 1 plus 1. Well, that's going to be the cube root of x cubed, which is x. So these functions are, I forgot how to write. These functions are inverses. Our next example, I have f of x equals negative 3x plus 12, and g of x is negative 1/3 x minus 12. So I've got f composed with g of x, and I need to find g composed with f of x. So this is f of g of x. So I'm going to substitute in g of x in for x. So I have negative 3 times negative 1/3 x minus 12 plus 12. That gives me, I'm going to distribute this negative 3. So I've got, and we have to remember to distribute, right? It can be very tempting not to, but we have to distribute to both. So I've got negative 3 times negative 1/3, that's 1. So I've just got x. Negative 3 times negative 12 is a positive 36, plus 12, oh wait, this isn't going to equal just x by itself. So I can stop here. There's no need to do g composed with f because these are not inverses. They are both functions, they are both one-to-one, but they are not inverses. Next, I have f of x is 2x plus 4, and g of x is 1/2 x minus 2. So I'm going to find f composed with g of x and g composed with f of x, so that we can determine if these functions are inverses. So f of g of x, I'm going to substitute g of x in for x. So I've got 2 times g of x, which is 1/2 x minus 2, plus 4. Distribute that 2, I get x minus 4 plus 4. So I get x. Now I have to check the other way, just to be certain these are inverses. I've got g of f of x. So I'm going to substitute f of x in for x and g. That's 1/2 times f of x, which is 2x plus 4, minus 2. So now I have x plus 2 minus 2, which is x. So these functions are inverses.